Alright guys, welcome to this page of the notes, and what I've got for us here, several more problems where first we'll need to show that the triangles are similar, because you're not told that, and if you can prove the triangles are similar, then we'll go ahead and solve for the unknown that I gave you. So that's where we need to start. Can I prove that these triangles are similar? Well, in order to do that, I need to show that two corresponding angles are congruent. And looking at the first one that I've given you here, right in the diagram I tell you angle S and angle T are congruent. That's what that little arc means. So I know that angle S is congruent to angle T. Fantastic. That's one. Now I just need one more. Well, actually, it's pretty straightforward. In both triangles, right, a vertex is R. And of course, R has to be congruent to R. So angle R is congruent to angle R, and there we go. Angle, angle, triangle similarity theorem. I know that these triangles are similar. So let's set up our proportions and see what we get. My first set of corresponding sides is going to be SV and TU. So let me set up that one first. TU over SV. And I know that TU over SV has to be congruent to RT over RS. So RT over RS. Well guys, now it's plug and chug. Don't fat finger something on your calculator. We're solving for RT. TU is 12 over 8, which is equal to RT, which is going to be over 10. Alright, let me come up here. Let's see here. Multiply the 10 to the other side. So 10 times 12 over 8 is equal to RT. And don't fat finger something on your calculator. You wind up with RT being equal to, I get 15. So the entire length from R to T is going to be 15. And again, that comes from setting up the proportions. I know that these guys have to be equal to each other because the triangles are similar. How do I know they're similar? I use the angle-angle triangle similarity theorem to prove that they're similar by simply showing that two corresponding angles are congruent. Let's do another one. Now in this one, we don't necessarily need to prove that the triangles are similar because what they're asking you to do is explain why. A student has already set up the proportion. They're telling you the proportion is wrong. They want to know how do you fix the proportion so that we do get the correct answer. So let's take a look at what the student has done. Well, the student has recognized that AB and CD are corresponding sides. So we have AB over CD. Okay, I need another pair of corresponding sides. Well, these guys right here, but you need to be careful. There's the entire length from E to A, and then the shorter one from E to C. So that means that I have AE over CE. Well, at this point, guys, we go ahead and plug and chug. AB is 14. CD is 10. That's all equal to AE. Careful. We saw this in a previous problem where we had to use the segment addition postulate. AE is going to be 8 plus Y. And there is our mistake. It is Y plus 8 at the top, not just a Y. I mentioned to you before that some of you might fall into that trap by thinking, oh, the entire thing, right? It's just going to be that CA bit, which is just Y, which this student did. Don't be that student. Please keep in mind it's the entire length of that triangle, A to E, which would be Y plus 8, all divided by 8. So what was the mistake? The mistake was they didn't give the correct length for AE. Alright, got another one for you here. Again, in order to solve for the unknown, we're going to have to prove that these triangles are similar. Well, let's start with the easy one. They share a common vertice right there. Obviously, angle A is going to be congruent to angle A. But then what? What else do I give you? Well, at this point, guys, we've seen enough times, it should be a red flag. You see those little arrows on the line ED and CB, which of course mean those are parallel lines. If I give you parallel lines, it's a really good bet we're doing something with parallel lines cut by a transversal, and sure enough, there's my transversal right there. So what do I know? Well, here's what I know. Angle C and angle E are what we call corresponding angles. In this intersection down here, right, I'm looking for that angle that's in the top right-hand corner. In this intersection, I'm looking for the angle that is in the top right-hand corner. Since angle C and angle E, the measure of those angles, are both in the top right-hand corner, they're in the same position. Same position means they're corresponding angles. So, angle E is congruent to angle C. Why? They're corresponding. Corresponding angles. Okay, you could have actually, guys, please notice, you could have done the exact same thing. Parallel lines, this time cut by this transversal. It turns out D and B are also corresponding angles. You could have said angle D is corresponding with angle, or is congruent to angle B. You get the exact same thing, and you got two angles. Anyway, here we go. Let's find my unknown length. All right, what am I looking for? Well, I want you guys to find the length of AB. Well, let's set up what we know. I know CB is corresponding to DE. So C, how about black? Geez, I did it again. Switch color, there we go. CB, DE. I know, right? I know the triangles are similar. I just showed it right here. I found two congruent angles, two corresponding congruent angles. That's enough to show the triangles are similar. So I know then that AB has to be proportional to AD. Great. Plug and chug, don't fat finger something on your calculator. I have 15 over 9 is equal to AB over 6. And pretty easy. Multiply the 6 to the other side. 15 over 9 multiplied by 6. Don't fat finger something on your calculator, and we get 10. So we found the length of our unknown side. Again, using two corresponding angles. They have to be congruent. This time it went back to corresponding angles. Again, from a previous chapter, using parallel lines cut by a transversal, but I've lost count of how many times I've said it. All of that stuff we've already covered. You're going to see it coming back. It's going to keep coming back. Please make sure that you are either brushing up on that stuff, going back and reviewing, or as we go through these notes, sort of recalling some of that information. All right, I got one more for you here before we move on to something different. Let's go ahead and do this one. Again, first I'm going to need to show that these triangles are congruent. Sorry, not congruent. I have to show that they're similar. And in order to do that, I have to show that two angles are similar. This one's actually really easy. I tell you that angle T is congruent to angle P, and, right, this is a right angle, which means that this has to be a right angle. So we know that angle TSQ is congruent to angle RSP, right? Those both have to be right angles. How do I know that? Well, this is a straight line, right? And so it is the, essentially they're supplementary angles. They have to sum to 180 degrees. The only way to do that, if this one's 90, this one has to be 90 as well. Or you could use the linear pair theorem. If you have two angles that sum to 180 degrees, which these would have to, right? Because it's a linear pair. If one is 90, the other has to be 90 as well. So either way you want to do it, you know that both of those have to be 90 degrees, therefore are congruent. And so we have the angle similarity. Now, finding corresponding sides. Here's what I would do with this one. It's a little tricky, and if you can't visualize it, I would redraw this triangle so that it has the exact same orientation. Check this out. Please feel free to do this. You will probably find it to be very helpful. I certainly do. I've been doing this for a long time. And I still, quite frequently, will redraw things. This one is S, Q, T. I know that this guy right here is 9, and this guy right here is 15. By simply redrawing that triangle, it'll now be much easier to recognize those corresponding sides, as opposed to when this one's laying down, you might fall into the trap of thinking, oh, side SP corresponds with side SQ. No, it doesn't. Side SP corresponds with side ST. But when this guy is laying over on its side, that corresponding side, it's a little trickier to see. Please feel free to redraw those, okay? Absolutely. Now, if you're, right, you sort of got the visual, spatial going on in your brain thing and you're able to spin those things around and manipulate them and see it in your head, awesome, good for you. Those of you who can't, redraw it. Just redraw it. So here's what I know. I now know that, let's see, PS corresponds with TS, and that has to be equal to SR over SQ. At this point, guys, plug and chug. Here we go. I know that TS is 15, so PS over 15 is equal to SR, which is 12 over 9. Multiply that 15 to the other side. We get PS is equal to 20. Hold up, careful, did I ask you for PS? I did not. Careful, 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 careful. I asked you for PQ, so now we go back to the original diagram. PQ is just this little bit right here. Well, how am I going to go ahead and find PQ? Yeah. Segment addition postulate. I know that PQ, sorry, hold up. I know that PS, the whole side, PS is equal to SQ plus PQ, right? In order to go from P to S, right, I need the little part here, SQ, and the part QP, or PQ. I gotta add those two segments together to get the larger segment. Well, now I just solve for the one that I don't know. 20 minus 9, in fact, let me go ahead and slide up. I'll plug all that stuff in there for you so you can see it. PS I just found, it's 20. They give me SQ in the diagram, it's 9. We're solving for PQ. So PQ, 20 minus 9, which is going to be 11. So watch out for that extra little wrinkle there, where what you actually solve for may not necessarily be what I'm asking for. Just make sure you read the directions really carefully. Alright, so guys, this is the way it's going to work. You first got to show the triangles are similar, then be able to set up and do the algebra. I got a few more examples for you on the next page of the notes. I'll meet you there.